Hello everyone, this is Hussaina on behalf of NowPurchase, and I welcome you all to today's webinar titled Achieving Sustainable Manufacturing with Advanced Technology. Just a quick introduction on what NowPurchase does. NowPurchase is transforming the 140 billion metal manufacturing industry in India. We are a SaaS-enabled procurement solution for metal manufacturers and are currently serving more than 200 manufacturers across West Bengal, Jharkhand, Maharashtra, Gujarat, and Tamil Nadu. We supply various raw materials, including scrap, pig iron, ferroalloys, modularizers, and additives through a network of warehouses and processing centers, as well as we leverage our exclusive supplier relationships, both in India and abroad, to facilitate seamless transactions for all our customers, both in India and abroad. We recently launched a range of private label additives and modularizers in-house, and we have a very competent supply chain. Along with that, we have a SaaS-based solution, MetalCloud, that optimizes and digitizes melting through a proprietary algorithm. This solution is integrated with WhatsApp and has IoT enabling. Some of our customers include Brakes India, Titagar Wagons, Kejriwal Castings, Tata Steel Limited, and many more. So today I'd like to thank all of you firstly for joining in for today's webinar. And let me introduce our keynote speaker for this session, Mr. Rahul Khajure. Mr. Rahul Khajure serves as the lead quality he serves as the lead supply quality engineer at Volvo.
Yeah, hi Purvi. I think Usana dropped off because of the internet connectivity. Usana, you're on mute.
We lost her.
Hi. Could somebody please let me know what they last heard?
Yeah, you were telling about Rahul.
Okay. So I was introducing our keynote speaker for this session, Mr. Rahul Khajure, who is the lead supply quality engineer at Volvo. He has been at the forefront of implementing advanced technologies to drive efficiency and reduce environmental impact. And we are very happy and grateful that he took out his time today to join us for this webinar. Along with him, we have Mr. Iqbal Naseem, who is the head of MetalCloud and has a wealth of knowledge in the latest manufacturing technologies, and has worked with several companies, including Indian Oil Corporation in the past, to help them achieve their sustainability goals. Together, they will provide invaluable insights and practical tips to help your business shine. And without any further ado, I'd like to hand this over to Iqbal, and he'll take it forward from here. Thank you.
Yeah, thanks Puri for the kind introduction. I would like to request Rahul sir to take it up first. Yeah, Rahul, you can go ahead.
Hello, Iqbal. I think you're on mute.
Yeah, am I audible? Hello?
Yes, Iqbal is audible now.
Yeah, so I was saying that Rahul, given the paucity of time, we'd request that you go ahead first, then I'll give my presentation, and after that we'll have a brief Q&A.
Okay. Yeah, thanks, Iqbal. And first of all, thank you, NowPurchase team, for arranging a session, this webinar. and it's always interesting to get connected with the peoples working in the same field, and we all are directly indirectly working for the technology of casting manufacturing, that is foundry. So it's always interesting to get connected, share our views, share our learnings and knowledge with all our stakeholders, and also try to understand about the the feedback, challenges, and then concerns what they share in our day-to-day life professionally. So it was first of all interesting session which was been asked to present, and it's all about sustainability. When we say sustainability, it's not only the emission coming from the product, but also a lot of things associated in terms of the business are also taken care in a sustainability. So let me share my screen, and maybe I will also try to express my views and uh, some information about sustainability. And let me know if you are able to see my screen.
Yeah, Rahul, it's visible.
Okay. Yeah, so as we mentioned, today's topic is about achieving sustainable manufacturing. So sustainability is a quite broad topic, and as I mentioned, we will be talking about the manufacturing, and there we will be specifically talking about the foundry as a business, or casting as a business. So before we jump more into the topic, let's understand first of all why we have to talk about this. I'm sure most of you would have heard about the term called VUCA world. uh, as of now, we are all living in this world. We are living in the VUCA world, which is more volatile, uncertain. There is a lot of ambiguity. Always there is a complexity. We have seen in recent past of, if you say, last 5 years, we have a COVID situation. We have two wars ongoing. We have semiconductor issues from manufacturing point of view. Climate change is happening, and so on. So the situation is quite uncertain, and important aspect of this uncertain situation is to be alive in this market. Okay, and to make sure that our business is sustainable, our business is alive, and we are becoming a more profitable from a business point of view. And how do we achieve is, first of all, it's important to make sure that we are taking care of a 3R. So we should be taken care of resilient. We also need to be regenerate, and we also need to research from a business point of view. And then let's understand what is really happening across the globe from a business, when we say casting as a business. So here we are having some important message from a casting or forging, basically the metallic segment point of view. As you know, there are a lot of the uncertainty, especially as an example, if you talk about developed countries in Europe, a lot of bankruptcies, financial distress, and inflation happening, and that is demanding rebalancing of global manufacturing. Many OEMs and MNCs are buying component across the globe, and because of this uncertain situation, a lot of rebalancing happening. And another reason, what we see is the direction in which OEMs are going is on the electrification. More and more sustainability has been spoken, and then there is also a good amount of pressure for the commercial vehicle, passenger vehicle manufacturer to go for electrification. When we say electrification, then again it's a different ball game, different technology involved. And when we say electrification, there is also importance of lightweighting. We need to go for advanced material, lightweight being material, and so on. And then third important aspect is sustainability. When we say long distance supplier, overseas supplier, there is a lot of transportation, lot of emission happening, and not only transportation, but from a manufacturing point of view also, there are a lot of emission associated. So these are some important point, but towards end is important to be competitive if you want to sustain in a business for a long term. Yeah, so these are some of the global trend, but what is really happening in India? So India is something different if you compare across the global world. Yeah, so there are some there are some key information about India as a country. So first of all, as many of you know, India is ranked lowest in terms of the recession in last few years, and that is consistently been taken care. We see many countries going for recession. There are a lot of inflation. There is a lot of job cuts and so on. India is also been considered to be a will be a third largest economy, and we will reach $7 trillion by 2030. So this is a remarkable growth when we say in terms of the GDP we are expected. We also have stable government in last few years, and I think a lot of policies are uh, facilitating facilitating the manufacturing as a segment. As an example, we also have a PLI scheme, production link incentives, which is also uh, pushing the manufacturing segment to go for more profitability. And end of the day, Miss, the India is also considered as a not a country anymore, but is also considered as a partner across the globe by many countries. So a lot of impact in terms of the strategies, policies, and the decision making across the countries happening. So which is positive and giving an advantage to the India as a country. So it gives a lot of opportunities also. So when you say opportunities, what does it mean? It also gives an opportunity to think and work in the direction of sustainability, to work in the direction of energy transition, means going for more of a fossil fuel. It also equally gives a pressure to explore more on innovation. We also need to be creative to sustain in a business. And considering as I mentioned, there are a lot of uncertainty. It also brings a pressure in terms of be more resilient. And if you want to sustain in a global supply chain, and we definitely we need to maintain a good quality, and that we achieve is uh, we need to go for a digitalization, automation, and efficiencies, and many more. So these are some areas where we see a lot of opportunity in India. Everyone in India is aware about this has to happen, or this way is going to happen. So when we say foundry as a business, as a casting business, what is being expected in a casting? So if we talk about casting as a business, not only ferrous or even a non-ferrous, there's some area where we have to focus more is more on digitalization. If we will also need to focus about the people with whom we are working, the peoples who are working for us, and also take care of the culture within the organization. And we also need to think about partnership and collaboration, because as an example, we all are expert in making casting, but apart from casting making business, there are a lot of other areas where we also need to collaborate. We need to use those advantages of the startup setup, and then try to achieve the common goal. And with that, we'll be definitely able to achieve sustainability. When I say digitalization, people's partnership and collaboration and sustainability, what does it mean? Let's go more in detail. So when we say digitalization, uh, as you know, the need of an hour, we are also facing challenges in terms of people working in the foundry. We are also facing challenges in terms of the quality requirement across the globe over the past year. Quality requirement are going more stringent. We need to compete with all global supplier base. So supply chain is more global, and that's how it's important to survive in the market and go for out of the box solution. So when we say automation, what automation we can do? So there are a lot of process still in a foundry which are manual and labor intensive. We need to explore those areas. As an example, post production activities of petling finishing. We also need to think about core handling, coating, this activity, which many of the companies in India started exploring now. We also need to think about avoiding many people standing in the shop floor and doing the inspection. So these are some area where we have to think in terms of the automation. But this is something not new anymore. A lot of foundries in India already started working in this direction. But if I say a lot, we have 1,500 foundries in India. Okay, that's a huge number. And among 1,500 foundries, there are a handful of foundries who are investing in this direction. So if we want to sustain in a business, these are the areas which are must to explore and must to invest. Second important aspect is uh, exploring artificial intelligence and digitalization in the foundry. So there are some areas where foundries are already exploring, and I'm sure many of you would have participated this year's IFX or GIFA. So there are a lot of solutions available in a market. There are many SaaS companies available in the market who are supporting foundries to ease their job. As an example, the inspection, process inspection, metallurgical inspection, traceability, data collection, analyzing the trend, plotting process capability, monitoring the systems in terms of the performance. So all those things are digitalized nowadays. These are the areas where we can reduce the dependency. The advantage of this digitalization and using AI-based solution is we can predict, and that's more important aspect. We can predict what will happen next. We can predict before you pour the casting whether the casting will be good or bad. Okay, so if you can predict the output of a casting, definitely you can take an action in that direction, and you can take a relevant action to make sure that castings are meeting the specification. Another important aspect is now industries are going for industry 4.0 solution, where people are exploring smart foundry solution is not only connected to digitalization but many more aspects. And then last important aspect is having innovation and creativity in what we do. uh, this is from my perspective is day out job at foundry. The way you design a getting system, the way you make design the tooling, the way you design the process are really important. I've seen foundries using, as an example here, batteries as a raw material, which is out of the box solution. You know, these are the pencil sized batteries using a steel cap, having a graphite electrode, and copper also. So, which are nothing but a raw material for the foundry, and these are getting from the vendors or from the government free of cost. So, we also need to be creative and innovative in this direction. These are some of the areas which we have to think and explore to be more competitive in the coming days. When I say partnership and collaboration, at Volvo, we say partnership is a new leadership. Why we say? Because as a company, we also as a company, as I mentioned, we are expert in terms of the making a truck. But as over the period of time, there is a lot of focus on electrification. There is a lot of focus on battery electric vehicle, but we are not expert in the fuel cell. We are not expert in charging station. That's how we do partnership with companies like Oracle, Callcentric, Samsung SDI, which are who are the expert in terms of making battery. Who are the expert in making fuel cell, who are expert in making the charging station available, and so on. So nowadays it's important to have a strategic alliance and even a partnership to make sure that we are meeting all the business requirement. So when we say foundry, what we can do with the foundries? So we expect our foundry suppliers to also collaborate with the customers, to have a partnership with the customers to achieve a common goal. So this is one of the aspect, but you don't need to restrict yourself with the customers. There are universities who are the expert in doing R&D, who are expert in terms of doing finding out of the box solution. So we also need to explore universities for a partnership. But third, but important aspect, there is also a big supply chain and the startups and the foundry supplier base who are available in the market. As an example, NowPurchase. So they have their own unique solution. So we also need to keep on exploring this supplier base who can solve our problem. Okay, there are companies, SaaS companies, there are raw material suppliers for you, uh, sleeve, filters, coating, binders, sand providers, raw material suppliers. These are the suppliers who are expert in terms of making their own product. We also need to utilize their expertise and make sure that we are collaborating and trying to solve the common issues. So this is one area where we have to focus and maybe explore more unique solutions to achieve a common goal and try to achieve a common success. Third important aspect when we say people, because as we know this is a labor intensive industry, we see a lot of challenge in terms of the availability of skilled people. So what do we do in this direction? It's very important to have the right talent in the foundry. We see there are very few um, universities providing a foundry as a course, uh, and we also see kind of a low interest within the new generation in terms of the foundry business. But we need to understand why this is happening, why the people are not motivated to work in the foundry. So in that direction, we also need to assess our facility, our process, and our capability to attract the new generation. So apart from that, what we see now, new generation is also more interested to be associated with a bigger brand,
रोहित हमको ये 98 ही
to
अपने
associate with a bigger brand, and important is to aspire to build our brand so that it attracts more people in this segment.
Okay.
Okay. I think in audience, can you mute yourself? Yeah, thank you. Yeah, so we also need to understand, first of all, how we can attract the people. First of all, we need to make a proper branding of a company. Second is important aspect is to make sure we have a right talent pulled for the foundry industry, and we also need to bring a brain. We also need to bring the cultural shift in this direction. So let's move on to the next topic on sustainability, which is an important topic for this session. So when we say sustainability and when we talk about global impact in terms of the emission reduction, so there are some figures here.
Rahul,
So
and now,
globally, we have 36 billion tons of emission, okay, coming from various industries, which are listed here, okay.
hi, Rahul. Hello.
There are the highest emission coming from a energy supply chain. Hello? Yes.
Hello, Rahul.
Yeah, I can hear you. Yes, I can hear you.
I think your screen froze. We are still stuck on the people and skill-oriented culture.
Okay. Let
Now,
me
it's
share
working.
once again. How about now?
Just a minute, it's still coming on the screen. Yeah,
Are
good
you
to
able to
go.
see the screen now? Yeah.
Yeah.
Okay. So I was mentioning there are various segments which are contributing heavily in terms of the emission, which includes energy, commercial building, industries, agriculture, forest, and so on. We as a casting maker are directly or indirectly associated with all these segment. We are making casting for forest, we are forest industry, we are making casting for agricultural industries, we are making a lot of castings for the transportation and automotive. Okay, so indirectly our contribution is also significant in terms of the global emission. Okay, India as a country is also committed to the Paris Agreement. When we say India will achieve net zero by 2070, we will also work in the direction intensively by reducing our dependency on the conventional source of energy. So India is also committed to achieve 50% of non-fossil based energy by 2050. That is a remarkable impact in terms of emission reduction from a country. So there are a lot of government initiative in this direction, and there is a lot of investment happening in this direction by the government of India, which means there is a good amount of promotion happening in this direction. As a company, as a Volvo, we all are also committed in that direction. As our commitment on sustainability, we are classifying our commitment in the direction of climate, resources, and people. When we say climate, as a mission, India has a ambition to achieve net zero by 2070, but as a company, we have ambition to achieve a net zero by 2040. In that direction, we are investing heavily internally and also working closely with our supplier partner. Coming to the net zero emission as a target, the target is also broken at a micro level. In that direction, we are also trying to achieve 35% of our vehicle sales, which will be fully electric by 2030. We are also trying to have a hydrogen powered solution to support the climate impact. We are also trying to work in the direction of resources to make sure that our facilities are landfill free, and we do a lot of circularity project. And on the people aspect, we make sure that we are taking care of diversity, female employees, and also avoiding the accident and so on from the people point of view. So as a supply chain, conventionally what we see there is a process called extraction where you extract the raw material, then you transform the material, and like in your case, pig iron, you extract the iron ore, you make a pig iron, you procure, you make a finished product, and you deliver it to the customer. So this is a conventional casting process. So the sustainable way of working is, post you deliver the product, it goes to the customer which uses this product, and then we have to recover the product, which goes back as a raw material, and it's a kind of a resource, and we use this resource once again. In this process we also generate a lot of waste. As an example, if you talk about machining process, during machining you generate a lot of machining burr. You, during casting process, melting process, you generate a lot of slag. That waste also can be recovered and also can be resourced either for this industry or some other industries. So this is a kind of circularity which we are expecting with all our supplier partners to explore. So no waste is a waste. Now there is a good amount of value to each waste. So we need to find a way to make sure that waste are not going for a landfilling, not creating a impact to the environment. So this is what we are expecting from our supplier partners, and this is what we should also think. So overall, as a sustainability towards the foundry, what we need to do, we are expecting all our supplier partners, first of all, to explore more of a usage of a green power, avoiding a use of a fossil fuel, really reduce our dependency on petrol, diesel, gas, and go for electrification. There are many solutions also available in this direction. Conventionally, as a simple example, foundries, there were many foundries using cupola, now going for electric furnace, but still in the foundry we use a lot of gas, diesel, petrol. As an example, we use the same for preheating the ladle, but now the ladles are also electric in nature. Even the steel plants are using electric preheaters nowadays. So we need to find a way to avoid the usage of fossil fuel, because the emission associated with 1 liter of diesel is like 3 liters of carbon dioxide emission. So that is a remarkably high. Apart from that, as I mentioned, we also need to focus on resources consumption. In the foundry, what we use is energy, one of the resource, water as another resource, and maybe sand, other resource. Yeah, I have seen many foundries. If you go to some of the belt, you see before you enter some of the areas, you see a lot of cores thrown across the road. A lot of cores and molds are used for landfilling. So that's not good. There are solution available in terms of the thermal reclamations nowadays, which can avoid the landfilling. So apart from that, we also need to drive efficiency project, reduce waste, avoid landfilling, and so on. So these are some of the sustainable way to make sure that we are uh, profitable within the organization. We are also sustainable, and we are also contributing to the environment. So as a responsible purchaser and as a responsible manufacturer, you have to take care of a climate, resources, and people. So as a dream, all the OEMs and MNCs are looking for a sustainable foundry manufacturing a green casting. And moment we start in that direction, I am sure there is certain amount of investment needed, but over the period of time, there is a good amount of improvement in terms of the profitability of business, and also the brand value for the company. So this is one of our dream, and I think many companies are already working in this direction. And here we need a more partnership, collaboration, and focus to achieve this dream. So towards end, what should I say is, together we shape the world we want to live in, and we have to take care of this planet. We have to take care of our business. We have to take care of our environment to make sure that is sustainable. Thank you. So over to you, Iqbal. Maybe if you have a question, we can take it now, or I'm not sure. You have planned to have a question towards the end.
Sure. Thanks, Rahul, for such informative session. I'm pretty sure many people might be having a lot of questions. So what we can do is we can have the Q&A session at the end. I'll presentation in brief, and by the last 5 minutes or minutes, we can have Q&As.
Okay, Iqbal.
Yeah, can someone confirm if I'm audible?
Yes,
Yes,
Iqbal, you're
Iqbal.
on.
And is my screen visible?
Yes, it's visible.
Cool. Yeah. So Rahul, you talked a lot about how the foundries should work on three key parameters, one being people, another being the resource, and third being the climate. And that's equally what we believe at, right? These are the three key resources which are actually consuming a lot of the word that the sustainable includes. So when we talk about the sustainability in terms of I mean, in general, in manufacturing sector, we generally talk about the energy, efficiency, waste, resource management, pollution management, right? But these are not the most important parameter that a foundry focuses on. So what I'll do is I'll be focusing more on the parameters where the foundry can take action to become more sustainable. That is energy, waste reduction, emission control, and the efficiency of the resources by which they are being utilized, right? So let's start with the energy savings. When we talk about the savings in energy, there are two ways you can save energy. One is by reducing the waste, and another is by reducing the energy consumption. And there have been multiple ways by which you could actually reduce the wastage as energy consumption. One is that when you optimize charge mix, another being that you have a strict over the quality, you check for the equipment efficiency, is that all your efficiencies have proper output, like there is no voltage leakage, there's no voltage leakage. Then you use scraps and pigs and other resources which are actually less in pollution nature, right? So let's say when I talk about the charge mix, so few things that are commonly being used in foundries are pig iron, metal scrap, bulk ferroalloys, carbon additives, ferrochrome and ferromoly, right? And if you look at the chart over here, you will see that the pig iron has the highest emission factor to in the bulk items. It has close to 1.8 to 2.4 kg of carbon emission per kg of pig. While if you look at the metal scrap, it's close to 0.4 to 0.7. So approximately almost 1/3 of your carbon is coming from the scrap, while the 2/3 of the carbon emission that you are generating in the pond is coming from the pig. And for this purpose itself, we have had multiple experiments. We did at the Breaks India. We are doing right now at Yash Metallics and Mantri Metallics. We did at Tata Ductile Pipe Plant, that the elimination of pig iron as a primary resource in terms of casting manufacturing, right? Typically, if you're a manufacturer of a grade 500/7, you are approximately consuming close to 500 kgs of pig in a heat, while your consumption of this scrap is close to 600 to 800 kgs, right? And when you use a charge mix of that scenario, you'll see that for every ton of liquid metal that you are manufacturing, you are emitting a close to 1.6 ton of carbon dioxide, which is actually a very humongous data. Hallar sir, if you need this slide, we'll share it with you over the email or WhatsApp. That's completely fine. There's no need for the photographs. We'll share the PPT at the end of the session. Right. And yeah, when you eliminate the pig iron as the primary resource and make the scrap as the primary resource, the emission per ton of the manufacturer of a 500/7 casting itself is 922 kgs, which is close to a reduction of 44.3% in the carbon. So just by eliminating one raw material in the foundry, you are saving close to 44.3% of the carbon that is being emitted in that particular process. And that's just from charge mix. This is one of the case studies that we did at Breaks India, that where we optimized their charge mix to fully use scrap as the resource, and there's no usage of pig iron, right? Another thing that you can optimize on is the furnace optimization, because when you talk about the consumption of power, close to 60% of power is consumed in the melting process, right? And one of the way to optimize the consumption of power in the furnace is to reduce the idle time, right? And how do you reduce the idle time? It's the time that is being taken by the worker over the melting shop, who are using that particular time either to solve a complex problem or either to do some kind of work which can be automated, right? For example, whenever there is a melt, people generally take a bath sample. Their spectrometer labs are close to 50 to 60 meter away from their furnaces. Someone has to take the sample, go to the lab, take the spark. Then there is the print option, right? And when you are printing on a paper, you are actually emitting a lot of carbon. And let's say a foundry doing a heat of close to 100 heats in a day is actually wasting 100 number of pages, right? And then there is a loss of the time that a guy is traveling from one place to another with the information. And the third is the time that is being lost in the manual calculation, right? So you can eliminate those things by having some kind of automation tool where these things are done for you automatically, so that you reduce the idle time as well as you reduce on the consumption of the paper, right? And one thing that you can also do is that elimination of loose scrap as well as the elimination of borings in unbriquetted format, right? So if you are going to use a scrap which is loose in nature, it will consume close to 650 kilowatt of energy in an hour. But if you bundle it, right, it will actually consume close to 550, which is a savings of around 15.38% in the power consumption as well as the CO2 emission. Similarly, when you briquette the borings, rather than using borings directly into the system, you will save close to 30% in the emission. And another good factor about directly put boring into the furnace, the wastage is much higher compared to when it's in the form of a briquette, right? Now, moving on, another thing that foundry can do to actually reduce the emission is having a tighter quality control. Like Rahul said, that before production, you should actually have a kind of prediction, right? And to have a prediction, you need to have some kind of data. Without data, you'll not be able to do any kind of analysis. So first thing is for any foundry is the raw material entry, right? And at the entry of the raw material gate itself, there should be some kind of check, and it should be a thorough check that the kind of product that you are going to produce, does the material you are buying satisfy the requirement of that production or not? If it's not the case, then that material should be rejected at the doorstep itself, because every other extra step you are taking is going to actually eventually lead you to the wastage, right? So if you're going to have 10 different steps taking over 2 days, 3 days, and making out a casting which is going to be rejected, which consumes a lot of power, labor, your time, then there is a lot of emissions, right? Those things are eliminated. So you need to have a system in place where you're able to reduce that. Then second thing is you should also have a quality check on each of your supplier. As Rahul was talking, right, that you have to have a close knit community with all the suppliers that you have. So you also need to evaluate which of the suppliers are actually performing better in comparison to the others, so that the next time when you're going to buy something from someone, you know these are the suppliers I can rely on who are actually doing something better, rather than having the suppliers who are of a mediocre nature, right? Because it again reduces the time that you are consuming, it reduces the resources that you are consuming, and it reduces the rework. Rework is the most evil thing that you can do for a foundry. Another thing is the quality control. When I talk about quality control, let's talk about the quality control in melting section. Husana, could you please confirm if my screen has changed?
Yes, it has changed.
Good. Yeah. So when we talk about melting section, right? This is the data that we gathered from the foundry. Close to 4,071 times out of 27,000, that is close to 1/6, right? Is the problem with the carbon. Carbon has been the major issue in the foundry. And one thing that I have seen in foundry is worked closely with 200 plus foundries, that people typically target a mean, have a range, let's say from 3.5 to 3.1. They'll always target a mean, because they believe that if I target the mean, I'll be able to get to the desired level in one step itself, right? And that's where the problem lies, because when you're targeting mean, it also means that you are actually consuming a lot on the additives. And if you look at the data itself, right, each kg of bulk ferroalloy produces close to 6 kg of carbon dioxide, and each kg of carbon additive produces close to 3 kg of carbon dioxide. Each kg of a ferrochrome will produce close to 5 kg of carbon dioxide, and each kg of ferromoly will produce close to 8 kg of carbon dioxide, right? And that is a worrying data which foundries do not typically take into consideration. right? So how do you solve for this particular thing, right? You need to have some kind of digitization that even Rahul talked about, right? That you need to have some kind of digital tools in your foundry where you're able to do root cause analysis, so that next time when you're going to produce something, you're able to predict. So let's say if you're able to track the number of hits that you are doing, and if the major cause of concern for you is carbon or manganese or silicon, you should be able to predict this, that if this is going to happen again, if I'm going to produce, let's say this grade again, why is it that I'm going to get an error in the production? And if the error, let's say, is going to be carbon, why is carbon the error for me? So that you eliminate it before you produce it. And that's how you save on the material cost. Similarly, once the melting is done and the part has hardened, then you go for a tensile test, right? Then this data also should be readily available with you, so that you can see what was actually done in the melting and what you got in the tensile. Was it something that was in the predicted range or not? And if it was not in the predicted range, what went out, right? And what are the control parameters which changed? So you need to have all kind of data in your phone, be it from your melting section, that is spectrometer, be it from the tensile machine that you are measuring, be it from the hardness machine that you have, be it from the microstructure. You need to have all kind of data connected to one kind of source where you are able to get each and every detail, right? So for example, this was the project that we did at Titagarh, that we completely digitized their log sheet, right? And in the log sheet, there is a lot of data which is available and which can be actually used for the pre and post analysis as well. So we gathered all the data for the foundry, and let me just show you. Yeah. So this is the kind of system we are able to get now. Now, if you go to your system in any day of the time or any time, you will be able to actually, I'm so sorry. Sana, has my screen changed?
Has changed.
You can see EFABC, right? Sana?
Yes, we can see that.
Okay, yeah. So this was one of the project that we did at Titagarh, and here you're able to see the liquid metal per ton that they are producing and the power consumption, right? And the heat distribution. From here, they are able to actually gather why they are having some erratic consumption of power, right? And because of this, we have eliminated a lot of unnecessary factors that are there in the production and have kind of brought it into a streamlined manner, that for each heat they're having almost similar kind of power consumption rather than having some kind of sporadicity that we have done. Yeah. Now, so let's talk about the eco-friendly practices that you can have in the foundry for having more greenery into the or more sustainability or less carbon emission in the foundry. One thing that you can implement is the solar panels, right? Typically, that foundries that I have been to have close to 5,000 square feet of carpet area that they have, of which close to 3,000 square feet is the area available for the solar panel. Now, if you put solar panels on these area, you can actually reduce the power consumption from the actual that we are having by close to 17.5%. Assuming that each solar panel can actually gives you kind of 4.5 kilowatt hour per meter square per day, you will be able to see that you can reduce your power consumption on day-to-day life in the foundry by 17.5%, which is directly translates into 17.5% reduction in the carbon emission as well, right? And the cost, if you look at it, that since the solar panel actually costs a lot, you will typically see that within a span of 3 to 5 years, you will be able to have a break even. I'm so sorry, right? And similarly, another thing that was very good experiment that I saw at one of the foundry in Coimbatore, that we waste heat resource, right? So what were they doing with waste heat recovery system was nothing peculiar, but something which is very innovative, right? And as mentioned earlier as well, that innovation is the key to solution. So what they were doing is the core that they have in which they are going to pour the liquid metal, that core was surrounded with the raw materials which was going to be melted in the next heat. and these raw materials were actually getting preheated from the heat that is being eliminated by the core. And because of this, they were able to save close to 30% into the system. So if you look at the power consumption data, close to 60% goes into the melting process, and in melting process the highest, close to 60-70% against goes in the furnace, right? Because you have to rise the temperature of the raw material. And what they did was key raw material was getting preheated from the heat that is being released by these molds after the liquid metal is poured into them, and then they were able to save a lot of energy. And if you look at the data, they did this kind of experiment into aluminum as well as the cast iron industry with insulation and without insulation. So with insulation, we were able to save close to 2 kWh of energy per ton, which is actually translates to close to 11% of the power consumption that's there. And with that, you will be able to save close to 500 grams of carbon per ton of the production of the casting. Okay. Yeah, so that's all from my end. We can have Q&As now.
Thank you for that very in-depth and insightful session, Rahul and Iqbal. Participants, we'd request you that if you have any questions, please raise your hands or write your queries in the chat box, and we'll address them. Thank you.
Iqbal, in the meantime, a question comes. I think one of the example in terms of the waste energy recovery system, what you have explained is very unique. I think this we discussed, at least I have discussed multiple times with many people, even with universities here in IISc Bangalore. We were trying to do a project. Concept is very simple, and we also know the energy law. Energy cannot be created, cannot be destroyed, converted from one form to another form. And we were thinking like, okay, you have 1400 degrees Celsius of metal, you pour the casting metal at liquid temperature, and you get a finished casting at room temperature. Where is that energy gone? Okay, and we spend a lot of money to generate that energy, and end of the day we get a room temperature casting, but in the process we are losing the temperature. Is there a way we can capture that energy? I think the solution what you have shown is really unique, but maybe many foundries will be looking forward for this solution.
Yeah, exactly, Rahul. So actually, I was sitting with one of my colleague, Rohit. He's also a graduate from Jadavpur University here in West Bengal and has worked extensively with the foundry. And I had the similar query. I asked him, ki, since you are raising the temperature of sand, right, and then it's cooling down, does this have any effect if I use this energy for something else? Maybe use the heat to make food for the needy. Maybe use this heat to just boil the water and use it as a solar water as the replacement of the solar water heaters or the normal water heaters.
Hmm.
So that's the kind of discussion I was having with him. And then he actually kind of told me that see, there is a solution that was actually tried, but since it's not very feasible given that the raw materials are very sporadic in shape and size, right? Key people could actually use these heat to actually heat the material that they are going to produce, because at the end of the day, the foundry wants a higher output. A higher output will be achieved if their melting is done in the highest efficient manner, right? And if you
Hmm.
preheat the material, you will actually reduce the time also that is being required to melt this. So let's say, for example, if a foundry is
Yep.
doing close to 70 heats in a day, they will be able to do 74 to 75 heats in a day. That's also one thing that was the added
Yeah.
advantage of it.
Yeah, so this is what circularity we are talking about. We have to bring a circularity in the work we do in the facility. uh, we have to reduce the amount of resources we are losing in the process. So electricity energy is a resource, okay, and there is a cost associated with this resource, and we are simply losing in this process of cooling. I think this is very unique solution. Maybe I'll connect with you separately to have more detailed discussion on this topic.
Sure, not a problem. And Rahul, one thing that I wanted to ask you about this AI and digitization in Foundry, right? So one thing that we've been consistently getting from the suppliers of the casting is that the foundries should be more digitized, right? And why is that the digitization has a much more impact rather than having some other kind of tool that the foundries look for?
Yeah, miss. See, Foundry is a process. We have n number of variables and millions of data available. Only challenge is that data is there in a paper. We are not able to use that data. When do we use the data currently is whenever there is a customer complaint, there is a rejection happening. That time we use that data. Um, uh, then we go back to the books and try to identify what went wrong. But data is already available. Now it's a matter of using that data, analyzing those data, and you then predicting what can happen. Will the casting be okay before you pour the casting? We know a liquid metal, we know time, temperature, metallurgical property. So that is what we have to do it. And I think we need more and more solutions in that direction.
Yeah, so that is also one thing that we have been continuously trying to achieve, right? Ki a lot of parameters are there in the foundry. That's why we are more into this digitization space. Ki if we could collect a lot of data, we could actually, at the end of the road, may get into something which can actually be something like of a eureka moment. Ki,
Yeah,
okay, this is the data. This could have been done earlier.
yeah, yeah. I agree with you.
Yeah, so that's all from my end. I think that there are no more questions, so we can end this.
Just wanted to ask everybody if there are any questions. You can raise your hands, or else we'll let Rahul and Iqbal go. So we'll just wait for a minute and then end this session.
Sure. And if someone is not very conversed with English or not comfortable in English, you can ask me question in Hindi. आप मेरे से हिंदी में भी पूछ सकते हो. You can ask me in Bengali. आप मेरे से बंगाली में भी पूछ सकते हो. I can understand Bengali and I can also understand a little bit of Marathi and Gujarati as well.
Yeah, I think the message was very clear during the session and webinar. I think it's very clear. So no more question.
Okay.
चलो, ठीक है.
Sure. So thank you so much, everybody. On behalf of the entire team, we want to extend our heartfelt thanks for joining us today for our webinar. Your presence and participation made this event truly special. And we hope you found the session informative and gained valuable insights to drive sustainability and efficiency in manufacturing. As promised, we will be sharing the recording of the webinar and all related materials with you shortly. We encourage you to review them and reach out to us if you have any further questions or need additional information. Thank you so much once again, Rahul and Iqbal, for joining us today. And see you again soon with another interesting webinar. Take care. Thank you. Bye.